we can start with simulation. There's a nice tool called Gazebo provided by Gazebo is independently developed, but this tool you can use it to simulate stuff, anything you want. It's a physics engine basically. So you can it's already installed when you install ROS. Can everybody run this sudo apt install turtle ROS hyphen humble hyphen turtle bot 3. It take around 2-3 minutes to install, but yeah. So if you installed it, can you create a Tmux window and split it into like one vertical, two over here? So for this, we don't have to create any workspace. We just have to, the binaries and everything have already been installed. It's part of the apt installation. It's all like playing Need for Speed or not, right? It says any car. We'll do something similar. Okay, so if installation is done, guys, just type this out in your thing. Export. Like first source ROS in all the terminals. Source ROS. Source ROS here, right here. So this tutorial you can even find online. I'm just walking you through how you can do this. Very simple to do. So once you source ROS, just export this environment variable. Turtle bot 3 underscore model equals to burger. Okay. Do that and then export Gazebo underscore model underscore path. This is a little long, so I'm going to I'll show the full thing over here. Gazebo underscore model underscore path. Guys, try running this command ROS2pkg prefix turtle bot 3 underscore Gazebo. See what you get. Export turtle bot 3 underscore model equal to burger. That's what we're typing. So this is the previous command. This is the first command. This is the second command. Just type that right now. What do you get any output? ROS2pkg prefix turtle bot Gazebo. Package not. It's not. Did the installation complete? Did you source ROS? Yeah. So package not found. Did you type turtle bot 3 underscore Gazebo? Guys, install one more package as well. You all install turtle bot 3, right? Just add hyphen Gazebo to that and install that as well. ROS hyphen humble hyphen turtle bot 3 hyphen Gazebo. I'll put it on the hyphen Gazebo. So Gazebo is a simulation engine over here. So there is a ROS wrapper for Gazebo. You all know what a wrapper is? Wrapper in software engineering means you are using something and you're building something on top of that. That's a wrapper. So Gazebo, there's a ROS wrapper for Gazebo. So you can use ROS to talk to simulation models in Gazebo. Gazebo is like a world. You can put objects, play around with things. If you, let's say, want to control a bot moving in Gazebo, you can use ROS to communicate with it. Yeah, ROS is a communication framework and you have an API to make use of ROS. And same thing with Gazebo, you have an API to make use of Gazebo. These guys have already written that. You don't have to do that stuff. Yeah, install for everybody? Yeah, I think now the prefix should be working. So, we already exported this burger thing right now. Over here, let's add this extra. ROS humble / share / turtle bot 3 underscore Gazebo / models. Yeah, just type this full thing. Huh? 3 / turtle bot 3 underscore Gazebo / models. 3 / turtle bot 3 underscore Gazebo / models. 3 / turtle bot 3 underscore Gazebo / models. 3 / turtle bot 3 underscore Gazebo / models. 3 / turtle bot 3 underscore Gazebo / models. 3 / turtle bot 3 underscore Gazebo / models. 3 / turtle bot 3 underscore Gazebo / models. 3 / turtle bot 3 underscore Gazebo / models. 3 / turtle bot 3 underscore Gazebo / models. 3 / turtle bot 3 underscore Gazebo / models. 3 / turtle bot 3 underscore Gazebo / models. 3 / turtle bot 3 underscore Gazebo / models. 3 / turtle bot 3 underscore Gazebo / models. 3 / turtle bot 3 underscore Gazebo / models. 3 / turtle bot 3 underscore Gazebo / models. Be careful, spelling guys is very important. Path is extremely crucial here. Seems like Turtle 3 simulation is not working in the system. What we can do is, can you all, there's a couple of model files in this. It's a Google Drive zip file. Can you all download this file in your PCs? Just download this and let me know. Guys, also, I hope everybody downloaded the zip file. Yeah, just extract the zip file and move it to a folder called .gazebo. There's a folder in your home directory called .gazebo. Okay, if it's not there, just create that folder and create a subfolder called models. Whatever, or just create .gazebo, unzip models.zip and push it over here. Yeah, sure. Once you unzip models.zip, you will get a folder called models. Okay, just move that models folder to .gazebo.
We should create a .gazebo.
Yeah, just create the .gazebo folder. Yeah, once you all did this, right, just open a new window, create a workspace called husky underscore double workspace. Oops. Yeah, it's already there. Create that husky workspace, mkdir husky underscore workspace, and create an src also. Actually, don't create src. I will show you. Just create husky underscore workspace and write this command. Yeah, once you all do that, right, source ROS in this terminal. Source ROS. Once you source ROS, run this command. Yeah, okay, so once you install the depths, right, just do colon build. Okay, so in another terminal, just run this command. ROS2 launch gazebo. Gazebo.launch.py. Yeah, run this guys. So guys, the thing you see on your window, that's essentially a model of the robot. This robot is actually made by a company called ClearPath Robotics. If you click on the wheels or tires or something, you can actually see you can interact with it. Yeah. I'll try exploring around this software. It's really good. So you can even try this if you want. Since we downloaded the models, try running this husky underscore playpen.launch.py. Yeah, like stop the previous process. I can stop it by pressing Ctrl C and then launch this. So what you saw first in Gazebo was actually an empty world, like just a grid, no objects, nothing. Just the model of the bot alone. Guys, in like as you run Gazebo, in another window, just type this ROS2 run turtlebot3 underscore turtlebot3 teleop underscore keyboard. That's it. So, guys, a small. I'll just finish the session and because work have to leave, I'll just explain this. Can I have everybody there? Yeah. So, thing is, the simulation which you are running, right? If you notice, when you press a key, bot is actually starting to move. That actually happens via PubSub. The keyboard node is actually publishing something called command velocity. It's sending a value. If you do ROS2 topic list, you'll find all the topics which is being used right now. I just try that out. In another window, do ROS2 topic list, you'll see all the topics. And if you do info for any one of them, you'll find out how many publishers, subscribers, what are the type of messages in that. Okay, so there are a few more concepts in ROS called services and actions. So topic you must have seen, you have one publisher, you have somebody publishing data to a topic and you have somebody subscribing to it, reading from that. So there's actually one more thing called service in ROS. Publishing and subscribing is generally used for sensor data or any volatile information, anything at high FPS. But let's say if you want to do an action, not an action, like if you want to do some immediate task, like let's say I want to request the ID of a robotic arm. Let's say a robotic arm is connected to your PC and you want to request something from it. Just request response kind of way. How you do it with a browser, you enter a URL, you get a web page, just like that. In those cases, you would use something called service model. I request something, I just get a response immediately. So you don't use that to send sensor data, but you just use that to perform any request any information, something like that. There's something called action. There's something called action in part of ROS2's SDK. Action essentially means a long running task. So if let's say you're moving from one point to another, that's a long running task. So that you can accomplish by using something called action. Action. You can give it a goal, you'll get some feedback, and once the action is done, you'll get a result. So if anybody is interested in continuing to learn more about ROS, I'll give my contact information to Abraham sir. You can contact him. I'll take a separate session, online session again. I did want to cover more things in the past 2 days, but could not due to time constraints. But I will definitely do an online session for anybody interested. So yeah, thank you so much for being. Thank you for being very patient.
I just want to mention a few things. So, like I mentioned, for the value-added course, this is the first session that. So this is one kind of half that Clay will be handling. So what we hope to do with the whole course is to, like I mentioned in the email and in the brochure, is to give you a full understanding of autonomous mobile robots. Okay. Now what we have done so far is Clay has kind of given you the tools which are necessary to do one half of it. That is to do a certain simulation or to run certain. I wouldn't say simulation. Some of these are required when you are running actual bots in the real world using ROS. So he has given you the software side of it. Now there are other concepts which are like the kinematics of it, the dynamics of this, and the fundamental basics of the different kinds of autonomous mobile robot systems that you have, and the various sensors and the actuators which go along with that. So we haven't covered that part. So that part will be covered by Dr. Mohan Krishnan. Now that will not be such a jam-packed session like we had the last 2 days. We'll have it over a period of 3 weeks after your cats are over. So okay, so the week after your cat, so the day after your cats, that's on Sunday, we'll have one small session, 2 hours in the morning, 2 hours in the afternoon, something like that. And then over the next 3 weeks, next 2 or 3 weekends, I think I've shared the schedule with you. So we'll do it over that. So that will not be just pure dry. What he will be doing is he'll be teaching you certain concepts, like for example localization, and then he'll also make you do certain simulations or certain assessments using ROS1. So he'll be using ROS, but we won't be using a native installation of Ubuntu. We will be using a VMware, and he'll also try to teach you how to use the ROS toolbox that you have in your MATLAB. So you'll be exposed to different kinds of softwares. So this would be a stepping stone, like I mentioned. So if you are interested later on, you guys can build on whatever you are interested in. It's not like a one size fits all. Robotics can be done in anything, and ROS is one of the major tools that we use. Okay. So hope this is useful to you guys, and thank you for the patience.